Good afternoon, ladies and gentlemen. Our topic today is on angle relationships, and we are going to be looking at lots of different kinds of angle relationships. The focus today is not just on showing you what these different relationships are. Most of them will be familiar to you. The most important thing is being able to tell the difference between them, remembering the vocabulary. Vocabulary in this video is extraordinarily important. So, first things first, our first kind of angle relationship we need to know is vertical angles. When you have vertical angles, that's anytime you have two lines that are intersecting and the vertical angles are equal. So the opposite angles are always going to be equal when you have two lines that are intersecting. In your notes, there is room to draw a picture. I need you to please draw this picture and label it with the 40 degrees here and here. We're going to be doing a lot of drawing and labeling throughout this video. So that one's very basic. Next, complementary angles. You've heard this term before. You should be fairly familiar with it. Complementary angles have a sum of 90 degrees. Sum means when the angles are added together, they add up to equal 90 degrees if you have complementary angles. So here's two different examples. I want you to draw both of them. One is a 45 degree and a 45 degree angle, which of course if you do 45 plus 45, they add up to equal 90 degrees. Just a quick reminder, a right angle equals exactly 90 degrees. So complementary angles are angles that add up and together form a right angle, a 90-degree angle. This one, 80, 10, add up to equal 90. You could easily solve a problem like an angle is 40 degrees, and the problem might ask you, what is the complementary angle? Okay, so all you'd have to do, complementary angle. All you would have to do here is figure out what you need to add to 40 to make it a 90-degree angle. And that answer would be 50 degrees. Make sure you're writing all of this down. Draw, label your pictures nicely with the degree measurements. I will be checking for that in class tomorrow. Okay, so those are pretty basic. Let's move on to another one. We have supplementary angles now. Supplementary angles are similar to complementary angles, except instead of having a sum of 90, supplementary angles have a sum of 180 degrees. Now I have a little trick to help you remember this. Supplementary starts with S. If you draw a line through the S like this, it looks like an 8. And there's an 8 in 180 degrees. If we go back to complementary, there's another cool trick with complementary. There's the C, draw a line, and that's a 9 from 90 degrees. Okay, little tricks to help you remember which one's which. So we have some examples here. Once again, draw and label the picture. We have 170 degrees and 10 degrees. Together, they make 180 degrees. When you put two supplementary angles together, when you put them on the same line, they end up forming an angle of 180 degrees, which means they're going to make a straight line. Okay, so two supplementary angles put right up next to each other create a straight line. Okay? Corresponding angles. This is something that is not, probably not as strong and solid for you. First thing we have to talk about is what this kind of situation is. In this situation, we have two lines that are parallel to each other. Write that down. Two parallel lines. And the line that crosses them is called the transversal. Label that, please. I'm running out of room. So, there we go. So two parallel lines, and you'll frequently see it say, cut by a transversal. And there are several important properties, several important relationships you need to know in this situation. The first is corresponding. And when we have corresponding angles, we have two parallel lines cut by a transversal, then the pairs of corresponding angles are congruent. So if you notice this angle right here, angle 1, okay, if we think of this as an intersection, say of two roads, straight and to the right, that angle right there, angle 1, is in the same position as if we took this intersection up and to the right here as angle 2. So angle 1 and angle 2 are in the same position of the intersections, and so we call them corresponding. Corresponding angles are in the same position of the intersections. And anytime you identify two angles as being corresponding, they are going to be equal. All right? So take these notes down. This part right here is in the fill in the blank section, and this stuff you're going to have to write off to the side. And we're going to work through an example. And in this example, you have a situation where you have two parallel lines cut by a transversal. So you have these corresponding angles. Because this angle and this angle are in the same place, so we know that they are equal. You can take these two angles, 2x plus 1 and 151, and set them equal to each other, like I have right here. Now when we go to actually solve this equation, you guys are really good at solving equations at this point, sorry. You would draw your upside down t, subtract 1 from both sides. This is algebra skills, you guys can do this. And oh dear, what have I done? Hang on, give it a minute. I clearly don't know how to work my smartboard. This gives you time to write it down. Hang on. 2x plus 1 equals 151. This is what I get for trying to record things ahead of time, isn't it? Okay, so here we are solving the equation. Subtract 1 from each side, which is going to give you the 1's cancel, and you end up with 2x equals 150, because we did 151 minus 1. And then, of course, you know how to solve the rest of it. Divide by 2. And we find out that x equals 75. Now, what you may want to do, or what some questions may ask you to do, is to take this value for x and then find out what these angles both equal. So we know this one is 151, but let's plug 75 into this equation. 2 times 75 instead of x plus 1. What should happen is that you should get the same value for both of these angles because they are both corresponding angles. Okay? The next kind we need to know about are alternate interior angles. And it's still, once again, two parallel lines cut by a transversal. And these first two words are the most important. Alternate, interior. Okay, so interior means on the inside of these parallel lines. You can see that angle 3 and angle 4 are on the inside. They aren't up here or down here. And they are alternate. That means that they are on different sides of the transversal. Interior means between the parallel lines. Alternate means on different sides of the transversal. Okay? Write those notes down, guys. These are important. And so we have a little definition, or a fancy math definition of this theorem. If two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. Congruent, remember, means equal. So this is another situation where the two angles are equal. And we're going to work through an example here of how we might solve a problem like this. So example 2, alternate interior angles, and we know that they are congruent, they are equal, because that's what our theorem tells us. So we take the measurements for both angles, 2x plus 20, we set it equal to 3x, and now we have to solve this equation, which is a little bit different than the last one because we have x's on both sides. So we need to get all of our x terms on one side, and we can do that by subtracting 2x from both sides. When we do that, we end up with 20 equals x, and there's our final answer. We now know that x, our variable, equals 20, and it would be a wonderful idea to double check. So if this angle down here, is 3x, it should be 3 times 20, so this should be a 60-degree angle. You might be saying to yourself, but Miss Ott, that looks bigger than 90 degrees, so there's no way it can be a 60-degree angle. It's obtuse. You can't rely on the way the diagram looks. People that make tests, including me, love to confuse you by trying to make the diagram look like your answer doesn't fit. Rely on the numbers. And what you'll see when you plug this value for x into both of these equations, now I've got 2x plus 20, which is 2 times 20 plus 20, which is 40 plus 20, you'll see that I end up with 60, which tells me that both of these angles are equal, which we know from our alternate interior angles theorem that they are congruent, so they should be equal. Okay, so use algebra to check your answers. Don't rely on what it looks like. All right, guys, here goes another one. We are talking about consecutive interior angles. All right, consecutive interior. Remember we said interior means inside our parallel lines. Okay, we knew that from the last theorem we did. Consecutive, however, means next to. So if we look here, we have angle 5 and angle 6. They're both inside the parallel lines, and they are next to each other. Okay, they're not on different sides of our transversal. So our nice fancy math definition, if two parallel lines are cut by a transversal, then the pairs of consecutive interior angles are supplementary. And a reminder, supplementary means, write this down, that they add up to 180 degrees. Once again, let's work through an example. We have here our parallel lines cut by a transversal. We have two angles that are on the same side of the transversal, and they are inside the parallel lines. So it is consecutive interior angles, and we know that they have to equal 180 degrees. So what we do is we take this angle, 81, and then we have to add this angle, 7x plus 15, because we know that supplementary angles add together to equal 180. Now it's just a matter of combining some like terms. We have 81 plus 15 is 96. Then we have our 7x equals 180 degrees. This is simply a two-step equation. You guys are really good at solving these now. Subtract 96 from both sides, giving you 7x equals 84. And we can find out what x equals by dividing by 7. And we get x equals, sorry, it's kind of hidden, x equals 12. All right, once again, let's check. This one tells us that this angle is 81. So let's plug 12 in for x. 7x plus 15, 7 times 12 plus 15. 7 times 12 is 84. If we add 15 to that, we end up with 99. So if this angle is 99 and this angle is 81, they should add up to equal 180 degrees because they're consecutive interior angles. So 99 plus 81, it does indeed equal 180, so we know that we did the problem right. All right, guys, the last example, the last topic, I promise, and then this video will be over. We have the alternate exterior angles. Exterior means outside the parallel lines. Whoopsie. Outside the parallel lines. Did I spell that right? Oh my goodness, my pen's driving me crazy. Sorry. There we go. Alternate means on different sides, remember this from before, different sides of the transversal. So if we look at angles 7 and 8, make sure you're writing these notes down, guys. These are really important. They are on different sides of the transversal. Our transversal is the line that crosses the parallel lines, and they are on the outside sections of the parallel lines, not in the middle. All right, so our theorem for this is if two parallel lines are cut by a transversal, then the pairs of alternate exterior angles are congruent. And of course, I have another example for you, example number 4, where we are going to find the value of x. So here we have two angles that are alternate exterior angles. We've got 125 degrees and 5x degrees. We know that alternate exterior angles are congruent, so they are going to be equal to each other. So 125 should equal 5x. This one's a real simple one to solve. Divide both sides by 5, and we end up with 25 equals x. All right, now we should, of course, check that. If we know that these should be equal, we take this 5x, substitute our value for x, 5 times 25, and we wind up with 125 degrees, which does, in fact, equal that measurement there. All right, guys, so let's go ahead and move on to our reflection question. I want you to solve for x. Tell me what x is. And then tell me what angles 1 and angles 2 equal. All right, so how many degrees they are. And finally, name the rule from today's lesson. So what theorem? First thing, solve for x. Second thing you have to do is tell me the angles, the angle measurements. And the third thing you have to do is tell me the theorem that you used to solve it from the notes today. All right? So you guys have a good evening. Sorry the video was a little long today, but I don't do that often and last night was short. Have a good one.